one of those other ones, and that's a good one that she picked out. It's a really good one. Okay. I had myself dressed in my right hand, so here we go. Oh, and I had to order a new print. Huh? I couldn't hear you. My sling, it's right over there. Yeah, I'm supposed to wear it more, but don't say that. Okay. So the biggest thing is I did this one right here, and I have a pointer. I should get the pointer by Friday. You know, like the latest pointer, because the other one died. Feeling sad about it. Last year, I swear someone stole my pointer because I had another. But this one right here is May, June 2012, 33. It's on your sheet, I believe, or did I give that to you? No? Yeah?
Maybe this sheet.
Do you have 2012 or no? Yes, you do? Okay, so if you take a look at it, let's see if I can find this as well. I'll try to read through it and everything else. And, let's see here. So, you know that I'm going to probably put a conjugate on there. And so, oh, we started this one, didn't we, right?
We didn't do B.
We didn't do B. So we did A, right? Well, just to go back, you know, like, hey, I forgot everything, you know, I was texted. I understand. Yeah, I got it. So, you know, let's talk about A. So they give this to you, right? They say U minus W is 4I, and then the product of those two is 5. So what do? So the instant you see this type of stuff, and it doesn't tell you what U or W is, you got to say to yourself, well, either one of them are the conjugates of one another. So you could have said, Mr. Tribble and company, I could have said that this was my U and that was my W, okay? And what we did was, so I'm just going to take this and its equal twin brother or sister. Remember, did I use that chorus illustration, right? And I get this, and then I go with this guy minus distribute the negative sign through this conjugate, and then one of the variables will disappear. Of course, since you see an I there, this I will also disappear. It's weird. Imaginary divided by imaginary is real.
It just goes away?
It just goes away. Isn't it weird? You never thought of that? Maybe it's just me. Okay? Isn't that the division, the quotient of two imaginary things over one another? Or
well, they're not real, so...
Ooh, we're getting more philosophy. See how math and philosophy... Yeah?
Okay.
Okay.
So I over I doesn't equal 1, it just cancels out.
They cancel out, but it does equal 1 if you think about it, right? Because
Yeah.
a number over itself is 1. But isn't it really weird that two imaginary things divided by one another is 1? Okay, that's it. So they disappear, they become 1, and you get B is 2. You take this guy and say, oh, well, it's the same thing again. You use the product, right? The difference of two squares, using the same thing in its conjugate. You get this guy right here. Remember, the inner and the outer terms disappear by, what do you know, by coincidence, right? And then this becomes negative, which is the same thing. And then you substitute in the known value of 2 into B, and then you find out what A is. And then when you do this, notice how the value switch. You find out that you get W and U and W as this corresponding. Okay? 1 plus 2I, 1 minus 2I. Now, you can get this other one as well. They accept this on the marking scheme. So it doesn't matter. Okay? Now, the hardest part is the next section, which was good old B, right?
Yeah.
Oh, yeah, B. This is the one you're all going to be like, how'd you get this right? And I'm ready. Hopefully I'm ready. So the first thing is they give you this right here, right? The the Z minus 2 plus I is less than or equal to 2. All right, so I should put a general thing here. When you see this absolute value and it's a less than sign, less than, greater than, less than or equal to, greater than or equal to, you know it's a circle, okay? You know it's a circle, and especially if it has this stuff inside here, okay? So with that said, okay, now, if I had this thing equal to another one of those absolute values, it's a straight line. Okay? I'm going to try, maybe we'll do one, we'll see. But I like the one with the circle. So when I see this one here, and unfortunately, remember, I can't write so high. So I have it here, so hopefully, oh, I should just give you like the solution if you're interested, okay? What I did is I saw this Z right here, and then I could have put in A plus BI, but what I did instead, because it wanted in real number format, I said X plus YI. Then I said minus the 2. These guys don't change, right? I just replaced the Z with this guy right here, X plus YI. Then I put the minus 2 with the X, and I put the YI and the 2I together. And then I did my little square, since it's absolute value, it's a distance, right? So that means I have to square these two things to form the circle. It's a little bit, like, oh yeah, sure. So then I have X minus 2 squared, Y plus 2 squared is less than or equal to 2. That gives me the center at 2 minus 2. I changed the signs, of course, if you remember. And then the radius is just that same value right here, which is 2. Now, I can draw this again if you want. There's the radius, which is 2. I went 2 on the real axis, minus 2 on the imaginary axis. Boom. Circle in the fourth quadrant with a radius of 2. So far, so good? Yes, sir. And yes, wait. Go ahead. Mr. Epler, and then Katie.
So then, when you said that you had a circle,
Yes.
but like sometimes it's not a circle, like for
Yes,
the graph?
right. When it's not a circle, that means I'll have this expression, so to speak, equal to something like, z plus 7. Absolute value of z plus 7.
But I thought it was just a solid circle with no shading.
Well, this one here, we're going to find out that the question asked for all the region, right? The region that all these things share. And
Yeah.
all those things share are those 3 lines, right? The first one's a circle, the next one's the argument of the angle, and the third one is there's 3 things going on here, right? And I should have yes, you're right. It's a circle that's shaded, right? But it asked for satisfies all 3 things.
So it's that piece of pie right
That's
there.
correct, yeah, I beat it to the punch, okay? And I'll pass this around, okay? Like campfire, it's not it. I got it, I
So
got
there's
it.
2 things, where one is a straight line and one is the
Yes,
circle one.
yes.
Is you layer them on top of each other.
Absolutely, okay, so if you're having trouble seeing it, it's right here, okay? Anybody want it?
I do.
Of course you do. It's like, I don't want to read it. I understand. Oh, hello there.
How did we go from the x plus yi minus 2 plus 2i to the next part? How did we
Here,
do that? Yeah.
because it's a conics thing, I tried to write it here. This tells me that since it's a distance and it's a circle is a secondary quadratic. It's a quadratic, right? So I didn't prove it. I have the proof over here how to do it. But since I know that it's less than or it could be equal, but since I only have this equal to some value or radius, so to speak, I know that these have to be quantities squared. Because sometimes, Katie, they'll ask you, hey, what is the center of that thing? And in order to have the center of it being a circle, that means it's this guy quantity squared, the other guy, the left-right quantity squared, and the up-down quantity squared. Remember your conics? X minus h quantity squared over a squared plus y minus k squared over b squared equals 1.
So you just,
That's what they're really doing.
you just switch stuff around from the first to the second.
Yes, ma'am. Yes, ma'am. I do have that. You made up a great question. I do have that if I can find it. I'll find it when you're gone, of course.
Okay.
Oh, here it is. Oh, yes. If you want it, it's yours.
What is it? Okay.
You asked how did I get this stuff to this guy, right?
Yeah.
There it is, okay? I just didn't have enough time to, hopefully just believe me that what I'm doing is correct. I know there's a little more gospel that's not wrong here. So I found the center, right? And I got the radius. And then Kemi's copies. So the next one says hey, so Mr. Edwards right. I have a circle that's really all filled, right? But it didn't ask for that. It asked for all of these 3 things that are going on, fill the slice of pie that everybody likes. You know, you like strawberry, but I like strawberry and blueberry, and she likes blueberry and blackberry. What's all the things that we share in life? It's saying that type of thing.
It's a pie.
It's a pie. It's a soup, okay? And it's a soup, a mess of soup or whatever, right? It's all combinations. So the next one is just a real. It says the real is z. If you look on the sheet, it says it's greater than or equal to 1. So that's just a straight line. It's like saying x is greater than or equal to 1. That's all it's saying. So that means it's just a straight line. And then it means it's all this stuff going this way, right? It would be, right? But remember, it wants what? Just a slice of pie.
Yeah.
So it's all of this, and then, of course, it's all the circle. You with me there? But we don't care about that stuff. We want to know where it's all, everybody meets together. We want to know where this graph, all the solutions meet with the circle in addition to the line from the vector, from the argument. You with me so far? There's 3 things going on in that question. Everybody okay? Sort of. It's coming around? Okay. Remember, this is all filled, but we don't care. This is all filled over here, but we don't care. And then oh yes, sir. That's right.
Cool.
Keep
Continue,
going.
yeah.
The next one is theta is equal to negative pi over 4. Well, you always start it on the x-axis, just like your trig, and you're going to go in a counterclockwise? Clockwise fashion? Clockwise fashion. Remember, the other one is clockwise, lefties. This one says we're going negative. That means we're going towards the 4th quadrant. And then that's this little angle right here. Okay? And that means we extend this line, and that's another one. Okay? Another portion. And so that means we're looking for all of this stuff, all of this stuff, and all of this stuff. What they share is this little slice of heaven right here. My wife made these pancake cakes. It's really good. They're really just thick pancakes. They came out pretty good today. And that was my dinner. I was so happy. And I had a little eggs too for protein. Yes. Go.
So if it was z minus 2 plus 2i is equal to 2, what would be the situation there?
That one would just mean it's the circle and there's no common points, right? You would just draw the circle. And so the only thing we would care about, and the circle would have no contribution because it's not an inequality. That's for 1. So you just draw the object, and it would just be this line, and by coincidence, this stuff. It would still be the same thing, but we wouldn't consider the circle. We wouldn't even care about the circle because it asks for inequalities.
I see. Thank you.
Okay?
Thank you.
Go ahead.
And if it was greater than, it would be everything that's, so like that blue line that you have, like
It'd be outside.
that outside stuff.
Outside
there.
stuff.
Yeah.
Okay? Outside stuff. All right? Not bad so far? I know it's like, oh my goodness. I know it. I know. But you copied it down and you're like, I'll digest it later. I know you. Okay? So it says, so the circle is, I have the points, and I just wrote this one. We have the circle, we have the line, and then we have the angle. And remember, we also know some things that are going on. And then it asked for the last section, it was the greatest value, something to that effect. Yeah? Because I spent some time. Maximum value, or whatever it is, right? Well, if you take a look at this circle, I know it looks like a really weird looking circle. Looks like the cat did it, right? From here to here is 2, right? Because that's the radius of the circle. And that the solution sheet's coming around, okay? So that's a circle. But I don't know this distance right here, right? I don't know that distance. So this we wrote as OC, and then this is CP, right? So to find the distance of OC is just going to be the square of those two values. And that comes out to the square root of 8. Now I just add it, so this one right here, see it's a triangle right here, Ryan? This little triangle?
Pythagorean theorem.
Pythagorean theorem. You're the man. You're the theorem. That's right. That's why I drew this over here, okay? So remember, this is OC from the origin. We don't know that distance, but we know this distance and this distance from those two values. So we square them, and we get 2 squared, 2 squared, 2 squared is 4 squared, plus 4 plus 4 is 8. Square root of 8 is 2 root 2. I left it the square root of 8, okay? And that's okay, because it didn't say to rationalize. So then I just have to say, okay, well now I know that this is the square root of 8. If I know that this distance is, let's say, 10, and I know this other distance is 2, 10 plus 2 is what?
12.
So if I know this is the square root of 8, yeah, and then this guy here is 2, then it's just going to be what? The
Square root of 8
of 8
plus
2. Whatever it is, yeah. Don't get me wrong, okay? Yeah. You know, I mean, like, yeah.
That can be like the first.
All right. Yeah. Okay, yes, sir. And I haven't finished it out yet. Go ahead.
Okay, then you can.
Keep going?
Yeah.
Okay, so the next thing was it wants the greatest value of res, right? Let's call it res, the real of z. So the real of z is this vine right here, right? And they wanted to know, I believe, this triangle. That's what I was thinking of. That's why I drew it. See, the arg is right here, and then this is the greatest value. So this is where I got a little bit weirded out. So I figured it out that it's going to be this line right here, OP, and for some reason I'm trying to figure out why it's the cosine of the angle. But I believe that it's another triangle that's formed in here. So they just took this stuff right here and multiplied it by the cosine of the given angle. I think there's a reflection thing going on here, and then, you know, like opposite angles or whatever is going on, and that's how I think they got it.
Oh.
I just didn't have enough time to tell you how they miracled it.
So
But I got this. Go ahead, Mr. Tribble.
So they took the pi over 4 cosine of that.
Negative pi over 4, yeah. And it's still positive because it's in the fourth quadrant. It doesn't matter. Yeah.
And then they just flipped it over.
Flipped it over, and then they multiplied it by the diameter. This would be so-called some type of diameter, right? It's better. It's shown better on the picture, right? It's a lot better.
It's very neat.
Thank you. Okay. What I was going to do is I can't go back and forth. I wish I had this a little over on this side, where I push a button, Michael, and it goes zzz. I bring this down, and then you can see the picture, and then my cheesy picture, and then you're like, we like this one better, right? So that's what I was
You
getting
gotta
at.
remember we go to Rockledge High School.
Yeah. Hey. You guys know Haley? Worrells? What's her last name?
Wardlow?
Thank you. I always say Worrells. Well, I've known it for as long as you guys, right?
Hue rules.
Hue worlds. That's right. So I got this. I was like, I am not using this hat to work in the. I call it in the field. My backyards, I call the back 40 like everybody else. It's like the fields because I got 3/4 of a backyard. And if you looked at my backyard, like, you want me to clean this? You know? Yeah.
Hey, you pay me.
And then you want, oh yeah. And you'd be like, you're not paying me that little. And I get food too. You'd be hitting me for per diem, you know, and so on. But I'm on teacher pay.
I'm gonna measure every square foot and charge you per square foot.
Now we're talking. I like your style, all right? Remember, if you're good at something, like the Joker says, never do it for
Never
free.
do it for free.
Never. Never. Okay? What's wrong with me then, right? And so that's the answer. And then make sure I get that back, please.
Right here.
Oh, you're awesome. Okay, so if you want to see it, it's right here. And it's also on, you want to see it? It's like, gimme. Okay? Okay. And it's right there. It's also on 8 Mundo. Okay? Maybe I'll throw that on the test.
Okay, so it's basically the question's asking you to find the maximum value of the real of that line, that Z line right there, at that particular angle.
Yes?
Okay.
Yes?
Okay,
Yes.
makes sense.
I think the picture's better, right? Is that one better? And you're like, oh, yeah. I got it. Hey, I remember I taught geometry, and boy, the kids were struggling because of my pictures sucked. But my proofs were amazing. Yes, Ryan?
Okay, so for the one, it's to sketch the Argand diagram, shade the region the points that represent. There are multiple inequalities.
Yes?
There is the one that has the Z, the number, and the I, and then
Yes?
a constant on the other side. That's the circle one.
Yes?
And then there's one where it's like, say if it were Z minus I is less than or equal to Z minus 2. That's a linear line?
Z minus I is less than yes, that's a line.
Okay, how do you
Yes.
clean that up to make it look like a line?
We would do the same thing that we did here. We go x minus yi, and we clear out the algebra. I can show one a little later if you want. I might have gave one to Katie in that locus of
Can you
points.
just do one of those?
I can.
linear ones just to get it.
Do you want remind? Is it one of those problems? What number is it?
No, it's the first one on the workout, number 7. It's
Number
I
7
got the
on 2000 whatever, or was it when I assigned or no?
It's on the
No.
homework one. Number 7 on the
Oh,
homework.
all right. Tomorrow, okay?
Okay.
Tomorrow. I know. I don't have much time. Yes.
So how did you know to replace the z with the x plus yi?
Because I know that a real number system, the complex numbers are broken down in a plus pi, so that's no different than Mr. Upper saying x plus yi.
So
Okay?
which one? Why you pick? Does it matter? Which
No,
one you pick?
no. Good question as usual. Okay? Doesn't matter. Because I could have said that this one's A and this one's B, right? But we use x and y. Up, down, left, right. Okay? Great question. And then I just multiply by this, and then I get the answer. Okay? Ryan, if I have some time, if I stop like 5 minutes or whatever, we'll look at it, okay?
Okay.
Because I don't want to neglect what you're saying. Now, this one, May, June. Notice I'm doing some of them that I had to like do the work, you know? Okay, and this one is 2004. So this is the pre-stuff, right? That you don't have the solutions to. So I had to struggle along with you. And to save some time, how much time we got, Ian?
12 minutes.
All right, so I got to wrap this up in 12.
As long as we're focused,
So I'm-
we got this.
Now, this wasn't that bad, right? It's in the beginning, it's like, but then if you practice it out and see, oh, that's what they want. And Ryan asked an amazing question. Oh, absolute value is equal, or this monster is equal to some other monster. And so all I have to do for Ryan's case is I plug in x plus yi here or whatever, and I do the same thing, and then I'll cross some stuff out. It's just algebra. I'll have to show him that in a second, so he knows what's going on, even though it's extra credit. This one, May, June 2004, we had the sheet, okay? Everybody there?
May, June 2004.
Yes. May, June 2004.
Number.
It doesn't have a number.
Oh.
It does. It's like the original sheet I gave you. Remember that one that goes up to 2009?
Yeah.
Yeah.
There's a bunch that's
The original sheet.
The original sheet. And I believe, hold on there.
The one that starts with May, June 2002. It's got like the earlier years.
Oh, number 8.
Number 8.
Yeah.
Oh, okay. Oh, sorry. I should put I'll put a number 8 here. Make sure someone puts it. I can't reach that high. You're taller than me. Okay. So this is what they're asking, and I want. Hey, they give you this Z guy, right? Oh, he's going to come on up to it. And they say, hey, using this, give us the solution. So if it's a quadratic, I like these. I like these. This is number 8. Ian, if you want to write number 8 somewhere, okay?
Oh, that's what yours.
Yeah. Any color, your choice of color. So this one says z squared minus z plus 1. Yeah, numero ocho. Yeah. All right? Or otto in Italian, ocho.
Quadratic formula.
Correct. I think quadratic formula. Now, you like which one? Complete the square, right? If you want to come up and do the complete square, that's amazing. If you want to put it on the side, under do not erase. I would love to see it if you want to do it. But I'm lazy and I didn't have enough time. I had to go to physical therapy. I learned some new exercises. Ooh, okay. But I graduate. I'm starting to graduate, you know. You're getting good, you know, one of those.
You can tell your Asian friend that you graduated from.
Honed in? Yeah, finally. Yeah, I graduated something above, something he didn't do. It's like this one-up thing. It's like my surrogate brother. It's weird. Okay. Because he's like, you don't have your PhD yet. I just. So you got the c squared here, right? I use the quadratic formula. Mr. Tripp, he's going to use the other one, okay? Right? If you want to put it up there in a second.
I'll try.
You'll try, and I'll help you out. So I use the b squared thing. I got a, b, and c. I put the values in, and notice I get a -3 in the radical. And so I pull that out, and comes an eyeball. Make sense? So it's 1 plus or minus root 3, negative root 3, I'll go down here. 1 plus or minus I root 3 over 2. And then I broke this apart into two possibilities, okay? And then it asked, hey, it should be radical 3 over 2. Then it asked, what are x and y, right? And those are the values. Remember, they're just the coefficients. That's what they're asking for. I think so. Yeah? All right, any questions on that portion of the madness there on May, June 2004?
Part I.
Part I. No question? Pretty easy, huh?
Yeah.
It could have said this, right? It could have said like, x squared minus x plus 1. Yeah, come on, give me a break, right? It just came out to be imaginary, okay? Or, excuse me, complex number, right? Because that's a real and imaginary. Okay, not bad.
So you said x is 1/2 and y is 3/2?
Yeah, radical 3 over 2. Okay? I was running, because I had to run to my PT, so. And I do have the answer if you want it on my sheet, if you want to see my sheet, okay? All right? So, there we go, radical 3 over 2. I'll do this. All right, any questions on the first part? I really like these. I think they're like, boom. You just take off and like, points. What am I doing tonight? Points. What am I doing tonight? And that's what you do, all right? Next one. Find the modulus. Find the absolute value. Find the radius, okay? I like to mix my absolute value with my polar, okay? Think of two dishes that you like to combine. And they would be what? Two good dishes. Besides peanut butter and jelly. That's
Rice
what
and beans.
Yeah. What else? Two good dishes that you...
Macaroni and cheese.
Of course.
Spaghetti and meatballs.
Oh,
Cheese and bread.
cheese and bread. Anything cheese, right?
Butter and anything.
Butter and anything. Butter and anything. Yes. Yes.
Pita bread and hummus.
That's...
You gotta say garlic
And hummus is really just chickpeas that are grounded up, right? Oh, I love hummus. So, I like to mix my polar with my absolute value. I put this in here, x 1/2 squared plus root 3 over 2 squared, and then I get the modulus of 1. Pretty good? Okay so far? Sophie okay? Brian, not bad? My dog ate my other shoes, and I had to get new shoes I ordered from Amazon Prime.
My friends my dog ate my shoes.
I had these, they were my dancing shoes. I had to take dancing lessons. You know, I do all this martial arts stuff, and I'm like, yeah, spin, kick, push this person around, throw them over my hip, get them like this, and he says mate. I love it. Then I'm dancing, I'm like,
Try not to beat someone.
yeah, I'm doing this. And my wife's like,
Hey, you gotta start somewhere.
Bakata in Japanese means dance. Isn't it weird? Yeah. I mean, I have no problem with that. So. Okay, so back, here we go. So, modulus, good old argument, right? Keep me going. Modulus, argument. Remember your mod and arm. And I'll put these two together if you want. So this is the y over x. And then that means it's going to be root 3 over 2. It's going to be the y guy. Remember the y guy. Hi, y guy. Over the x guy. And I put root 3 over 2 over 1/2. And one of them is a negative as well, right? Because it's minus for both roots. So that comes out to be 60 degrees. If you keep it in degrees, I probably wouldn't take off. If I'm in a bad mood, I will, okay? But usually I'm like, all right, radians. And hopefully you're not that last paper I'm doing. That last person I grade usually is like, you know. But you get the idea, all right? So pi over 3 or 1.05, right? And the other one's the same thing, and minus 1.05. Because the only thing that changes is the sign. Okay? Now, the extra credit one here, if you really want to know, put the mod and the argument together, right? That means it's this guy right there. So what I would do is I would write, let's just go modulus argument. So I can go, remember to be R, remember cosine theta plus I sine theta, right, is the general from de Moivre's theorem. So R was 1, right? Man's lazy, doesn't write the 1. So then, sorry girls, right? She's like, oh yeah, we know. Cosine, it's just weird how right-handers written. Okay, cosine of pi over 3 for the first one, plus I sine of pi over 3. That would be the first guy. And then the next guy would be the same thing with a minus 1, minus pi over 3. Or negative 1.5 or positive 1.5. Boom, boom. Because I can say for, I would like it, this is an extra credit question just in my head, just thought about it right now. Put the modulus and argument together in using de Moivre's theorem, or de Moivre's form, DMT. That means you're just going to say 1 here, right? Man's lazy doesn't write. And the other one will be a minus sign here, and then that's it. Pretty good?
Yeah.
Easy? I told you I like to mix my beans with my rice, right? All right. For some reason I hear that song in my head. I like beans plus rice and beets, I'll mix them. Okay, yeah. Go ahead.
We do triple I?
We're going to do that right now. All right? I'm almost coming to the end. Now, it says z to the third is minus 1, right? You got to cube it, right?
Yeah.
Oh my goodness, I'm going to die, right? You're smarter than the average bear because you're sitting here. So the big thing is I just made this an equation. You didn't have to. No. You could have just kept it that way. You could have took the cube root of negative 1, right? Well, you know one of them is going to be probably negative 1, right? And the other one is going to be most likely imaginary. What I did here is I used my sum and difference of cubes. Remember those?
Yeah.
And I would give those
Yeah.
formulas to you. Okay? I don't expect you to remember for the sum a squared plus b squared, parentheses, a squared plus minus 2ab plus b squared, and then minus plus plus. I wouldn't make you memorize those. Okay? So I broke it down, and I got it down to here, z is minus 1. And guys, look at that. This one is no different than the one that we did on top. You see that? Clever, huh? Clever. Yes, sir.
So you just replace the
Yeah.
A's and the B's with Z?
See how I'm so lazy? Yes. Yeah, I just replaced the A's and the B's with the Z's. Yeah.
So the A and the B is kind of like...
Yeah. I must have,
Never mind, yeah.
Never mind, okay. All right. Not bad? Okay. First of all, is it okay for me to write this stuff and then go through it like, the Peanuts adults? Yeah? Wah, 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 wah.
I prefer the other way.
You prefer me to write it?
Yeah.
Let my arm get stronger,
Yeah.
okay? Because then I go too fast. Let my arm get stronger, because if I'm writing the right hand, I do this.
Yeah.
I'm like
It's
that.
understandable.
Yeah, you ever see the Geico commercial with the sloth?
Yeah.
Well, that's how I feel, okay? And then he does this and smiles.
Well, sloth is-
Some of those commercials are so stupid, but they're funny. It's like when my brother talks. It's just like,
The stupidest commercial I've ever seen was that Super Bowl one with the puppy monkey thing.
that made no sense at all. Because that's like the Christmas or the Super Bowls of commercials too, right? Because that's what we were just talking about, right? What were we talking about?
we were talking-
You
yeah.
and who else?
Katie.
Katie, yeah. Take a look. If you have any questions on the homework, come see Ryan tomorrow. Okay?